Okay, so uh, so today we'll be talking about the introduction to Internet of Things, and like we'll be understanding the basic idea of Internet of Things, how it is defined, and the basic characteristics of IoT. So the aim of this module is to understand the concept of IoT, uh, understand its use cases and applications. And also at the end of this module, you'll be designing an IoT system, and then you'll be like designing that IoT system based on the user requirements, based on the specific scenario that you're considering. And then you'll be specifying the like the devices that you're using, the communication technique you are using, the protocols you are using, the database that you'll be using to store the data, and the policies that you're defining for the data transaction. And also after collecting data, you will be able to do some analysis of the data, right? So those are the basic things that are related to IoT. Currently, when you talk about this data analysis, we have this machine learning predictions and forecast of systems as well, in order to improve the performance of these systems. So based on the customer requirements, we need to give the required data, and we also need to optimize the system by understanding what are the parameters that affect the IoT system's performance, right? Like, for example, if a certain parameter is affecting its cost or its energy efficiency, its latency, responsiveness, or the accuracy of the data, we need to improve the system by understanding in what like situation this occurs, uh, right? In what situation this challenge occurs, and then we need to address those challenges, right? So as like engineers, we are expected to design IoT systems in this module, right? So in order for us to design an IoT system, we need to know like in overall what an IoT system is and the components of a basic IoT system and so on. And so in this module, the module outline is given in LMS. However, I think the module outline will be updated in the future by adding some more like content to the module, apart from what are already there. Right. So the definition of IoT, right? So have you heard about this IoT term somewhere? I'm sure you must have heard about this because it has been like a very popular like a term in the tech field, for example, and people are also very much interested in this IoT concept because they can, connect devices like anything, like it could be our smartphone, or it could be a sensor or a processor, right? Any kind of like a stationary object you can connect to the internet by using several technologies, right? So this is mainly the definition of IoT. So it is the technology that connects a network of physical objects, or we call them as things, that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices or other systems, and or other systems over the internet, right? So this is one definition that had been given about the IoT. So anyway, what happens in general in the IoT basically is that there are some devices that need to get connected to the internet, and also these devices have ability of sensing its environment. So it can sense some certain parameter in the environment, for example, like the pressure, the temperature, or anything else, like humidity, the level of carbon dioxide. Likewise, it can sense its environment, right? So this device it now wants to connect to the internet somehow, right? Because by connecting to the internet, it can communicate its data to its user, to its customer who wants that data uh, at a remote location, right? So anyway, the device wants to now connect to the internet. And for that, we need connectivity, right? Communication technologies, right? For that, we can use either wired media or wireless media, right? So most of the time, actually, IoT uses like wireless technologies in most of the times, right? So we can see Wi-Fi connected IoT devices, we can see Bluetooth connected IoT devices, and cellular network connected IoT devices, and so on. So anyway, we need both sensibility at the devices and connectivity at the devices in order for the devices to connect to the internet and form an IoT, right? So I hope you understood that. So in an Internet of Things network, we have basically several components like the device or the thing, we call it. And then we have a gateway where we send our data to get, like kind of collected at one place. So it could be like a local server which has connection to the internet, right? So this gateway is like a local server and it's connected to the internet, and then it sends its data to the cloud. And then from the cloud, the data is getting stored in a certain database, and that database will be used to analyze the data that we have collected, right? And then using the collected data, we can visualize the performance of the system with respect to the certain parameters or certain like measurement that we have taken. And then based on the output, we can give some idea to the user by using a certain user interface. So we call that user interface. We call that user experience. So so at the end, what we want to do is we want to give our customers an idea about the certain scenario that they are considering, and the certain application that they want to know some more information in. So the goal of the IoT is to create a more connected and efficient world by automating processes and improving decision making based on real-time data, right? So IoT systems are used mostly to automate processes and improve the collection of data autonomously at locations, at certain locations, and then use such data to make decisions, use such data to um, make our work, our activities easier. So IoT is used for different applications. So once we have our sensors or our devices at remote locations, it is easy for us to automate those devices and make them collect the data and then use such data for our own use cases and for our own advantages, right? So do you think that do you need IoT in day-to-day life, right? So I think IoT is something that we are using every day, right? So when we take the smartphone, for example, a smartphone is a device which is getting connected to the internet. Apart from that, our phone is able to sense its environment, right? For example, we can take, for example, GPS, and then other sensors which are in our phone, which can collect data about its environment and use that data and then upload it to the internet, right? So we can we are currently using our smartphones in our day-to-day lives. Also, we can use the sensors in the phones to use it for more, like maybe more complex activities than what we are using it for. And also, like even the simplest task we are doing via our smartphones, we can consider as one of the IoT applications. And then there are some devices that we can connect our phone to, and then we can make it work, right? For example, we can connect our phone to maybe music like speakers in our homes, and then to other devices like maybe the refrigerator or some other equipment which has the ability to connect with the smartphone. And then with that, we can create a smart home concept. And then using that, we can create like an IoT system, even using our smartphone. So how do we prepare an IoT system based on the user requirements, right? So one of the goals of this module is to design an IoT system based on the user requirements, right? So we can take for one example, like smart agriculture, right? So the user might say they want to know about the moisture in the soil, about the condition in the field, it could be the paddy field, and then they want to know about the humidity in the air and the temperature in the environment, and also about the radiation level in the environment and so on. So based on these requirements of the farmer, we can, design a certain system with a certain architecture that allow us to collect such data and then communicate it to a certain local server, and then use that information and then forward it to the cloud, and then do the analysis in the cloud, and then communicate it to the farmer, who will receive the information of the final results gained by the collected data, right? So for this case, we need to consider about the architecture of the system, right? So the architecture of the system means like what are the equipments you need, right? And what are the softwares you need? What are the technologies you need? The protocols and so on, right? Everything that you require to form an IoT network is part of the architecture, and how they combine with each other and how they relate to each other is defining the architecture of the IoT system. And then we also need to put some rules and policies and the protocols for the data transactions and the data management, the security of the data, and so on, right? And then, so we need to consider about the quality of the data. So we need to like make sure the sensor measurements, the sensors have high accuracy, and we need to transmit the data in a wireless channel. If we are using a wireless channel, we need to make sure that the data reliability is maintained, and that real-time data can be transmitted in that certain scenario, right? And then finally, once the data is received at the user end, the user must be easily able to get the information from the uh, user experience interfaces that you have created, right? So maybe you can create a software like a mobile app for the user to obtain the data that that person requires easily without much difficulty, right? So these are really trending topics in the current IoT systems. And then I don't know whether you have seen this, but there are so many job opportunities for like user experience engineers and user graphical interface engineers. And also now the trending topic is like cybersecurity, right? The security of the data, and also about cloud computing, right? Cloud computing, security, user experience, and also machine learning. So these things are trending highly these days, and those are the topics that are really needed for our IoT system designs. So we will be going through those things, those topics in this module, and therefore I believe that this module covers most of the, I mean, general idea of all those topics. Maybe we might not go into the some to the very deep deep end of those areas, but we will be gaining enough knowledge to apply it for a certain scenario. That is the objective, right? So as I said before, like once we are given certain system specifications, we need to design an IoT system, right? So this is the second goal of this module, where we are given like some specifications by the users. The user is telling, I want to use these sensors, and then I want to collect these measurements. And also I want to use this connection technology, right? Like LoRa communication technology. And then I want to send that to the cloud and do, like calculations, and then show the results in the apps and so on, right? So once the user is telling us that they want to use this technology, they want to use this sensor, they want this parameter, we need to incorporate that into the IoT architecture. So in order for you to become an IoT designer, right? So IoT is, as I said before, a combination of multiple technologies, right? So it could be better if you have basic understanding of programming. So if you can learn about Python, SQL, and so on, I think you will be able to do well not only in IoT, but if you're going to develop some softwares and so on, Python is going to be helpful. So Python language or some other programming language, you can learn such that you can use use that skill to design an IoT system, right? And then research on the latest trends, right? So you can find out in the Google, in the books, or you can talk to people in the area, in the industry, in the maybe academia about the IoT trends and what are the best technologies that go with the IoT trends for maybe a certain application and so on. And then we can talk about research and doing some research and implementing a system based on the results that we found from the research, right? The conclusions that we got from the research. And then we can have some hands-on experience in existing IoT platforms, right? So there are big companies in the world who are implementing these IoT platforms, but also apart from that, they also allow us to use their resources, right? So that is the advantage of having this internet connectivity and the access to resources, so that we can now connect to IoT platforms and learn about them without much difficulty. And there are companies who are implementing these IoT platforms, and most of the infrastructure is already built. And the user experience, user interface design is also something that you can be good in order to be an IoT designer, right? So anyway, I mean, you can have all these skills at least up to a certain level, and that will be enough for you to be an IoT designer, right? So user experience in this in this slide, I mean, is like developing software apps and so on. Actually, Navod, actually you can, if you can use Cisco, I think Cisco Packet Tracer is available for free. I think if you, I think I haven't really planned the assignments yet, but I just would like to know whether you have used it before or not. If you have used it before in your previous module, one of the modules, or in some of the modules before, I think I'm not going to be implementing that in this module. So can you please, let me know in the chat whether you have used it in your previous courses, Packet Tracer software. If you did not use, it's okay. We can use it in this module and we can learn about it. So you can let me know in the chat. So now, though others, please let me know whether you have used it. Okay, you have not used in this in SRTC. Okay, so okay, so I think some did you okay, some students I think have followed the course, I think called Internet Technologies. Have you followed Internet Technologies course? Because I talked with them and then they said that they are using it, but I don't know about whether you have used it. I think maybe you haven't. So anyway, we'll be going through that software as well. So thank you for letting me know, right? So we can use that and then we can actually learn it to like configure like smart home systems and other like automated like IoT networks. And then we can, uh, define certain parameters and define the certain protocols that we are using to connect the devices. And then we can, see how we can like control the devices at a remote location, right? So I think Cisco Packet Tracer is one software that you can use. And so in here, in this slide, what I'm mentioning are some other like IoT platforms like that we can use to learn about IoT and how it is implementable in the in the maybe in their infrastructure, right? So AWS IoT, that means Amazon Web Services IoT, is having like a developed infrastructure, and then they allow us to connect our devices to their platform, and then use the data. Uh, uh, I mean, send our data or send the device data into the cloud, and then it allows us to collect the data over a certain time period, and then visualize the data, and we can do some more tasks after visualizing the data. So the whole process is possible using Amazon IoT, AWS IoT, and there are other platforms like Google Cloud IoT, Azure, Microsoft IoT, and Cisco IoT, and so on. So I think we can go through some of these platforms as the time permits, and also like as it is required in this module as well, right? So once we are learning like the basic architecture of this IoT, we will be going further into how we can develop the IoT network in the cloud using the available existing platforms, right? And also we need to consider about the cost of using these platforms, right? Sometimes we need to pay for some services, but I think we can access free options as well. So up to some extent we can use the services given by these platforms. So the key elements in an IoT platform, for example, like we can take Amazon IoT, we can take, and then the platform, the IoT platform must consider several key aspects which are related to these like factors, right? So one is protocol support, right? So IoT systems are basically collecting like massive amounts of data, right? So within a certain matter of seconds, we need high amounts of data transactions happening from one point to another point, right? So from the sensor end to the local server, and from there to the cloud. So because of this, we require like low complex algorithms or protocols to transfer data. And such kind of protocols are required for data collection, I mean data transfer, communication, and so on. And therefore we are looking for low complex, less complex protocols, and also low power devices, low energy consuming devices to collect data, right? At the sensor node level, we prefer to have low energy consuming devices, and use maybe like techniques to conserve energy as much as possible. So there are many technologies which are coming in the future as well. It's related to energy conservation, energy harvesting, and so on. So that is the first thing. And the second thing is that we need to be able to facilitate like massive amounts of device being connected to the IoT platform. And then the IoT platform must be able to receive like high amounts of data, right? So it is expected that like petabytes of data are going to be transferred from the device level to the IoT platforms, right? So massive amounts of data rates are going to be required in these systems, and then the IoT platforms must be able to facilitate such data rates. The third thing is that the security of the data must be maintained, right? So once there are so many sensor nodes and devices connected to the IoT platform, we need to maintain the security of the data by using certain, encryption, decryption methods that we have, and then also we can use several, private keys, public keys to, secure the data, right? So we need to have a policy in the IoT platform to enable only the authorized users to use the platform. And fourthly, we have integration and analytics, right? So in there, we are trying to analyze the data, and we are trying to get some information from the data that is collected, right? So we are going to make decisions. We are going to focus the system's performance with respect to the certain parameters that we are considering at that certain scenario. And then we are finally considering the software toolkits, right? SDKs, right? Software developing toolkits that we can use to make the data more like easily understandable to the customer, right? So the advantage of IoT is therefore having an automated system that can collect data at a remote location, and that you don't need to be there, but the sensors or the devices at the IoT end or the edge of the IoT will collect the data for you, and will send the data to you across the IoT platform, right? And then also user experience, right? So when we can, gain data over a lot of time, over a longer time duration, we can take a good decision about our IoT system, and then we can also improve the output of the data collected and visualize it in a way that users are able to understand the performance of the system and the meaning of the data that is collected. And thirdly, IoT enables us to innovate more more systems for our day-to-day tasks and other tasks which could be industrial or any other tasks which are related to public requirements. And then also we have connectivity, right? So IoT provides us connectivity. It gives us the ability to know or gain information about certain like a location with respect to a certain parameter, right? If I want to know like the traffic density in a certain road, right? I'm just Googling in the Google map, and then I'm finding that there's traffic there, and I don't need to like wait in the traffic. I know beforehand that there's traffic, and then I will avoid that by using other means. And so therefore such kind of applications make it make it useful for us to have a very like a good IoT system that gives us useful information. And then IoT systems reduces the cost of systems, like in general, because we are not doing things individually. We are not measuring like data manually. We are making the devices do it. So we are actually saving like money and time. So with respect to those such kind of parameters, we have reduced like cost when we are using IoT systems. Okay, so I think there's a video that I would like to show as well, but I think I will upload this presentation, and you can, view that later and you can learn about the applications of IoT using that video. So even before I talked about this topic, so can smartphones be considered as an IoT device? So IoT device is defined as a device which can connect to the internet and which has the ability to sense things, right? So smartphone is able to sense its environment using different sensors which are installed in the phone. So a smartphone specifically has more performance in terms of sensors rather than the traditional phone, which does not have a connection to the internet, and sometimes it does not have connection to the GPS signals, right? So the smartphone has GPS connections, it has Bluetooth, Wi-Fi, and then it has, therefore, it has the ability to connect to the internet. And by using all these services, it can, even estimate its own location, like by using the GPS sensor and so on. So it is a very good example of an IoT device, and it is an IoT device, but the traditional mobile phone is not an IoT device. And there are certain organizations that define the standards for IoT networks. So industries, when they are developing IoT networks, they must follow these, standards defined by these, companies, in order for all the industries to follow the same standards, right? So otherwise, like one company could, develop one IoT system, and the other company could develop another IoT system. But because of not following the standards, they might not be compatible with each other, right? So because of that, these, organizations that define these standards are telling these companies or the organizations to follow these certain procedures in designing their IoT networks and their architectures, such that it is compatible with any of the, technologies or other different IoT systems that are getting connected to them. So I would also go briefly on the history of IoT. So the first IoT device is said to be a Coca-Cola machine, which was, connected to the internet, and then which was connected to the internet through, I think using Ethernet cables, I think wired media. And then they have had some sensors in the machine that enables us to sense the temperature of the Coca-Cola and also the availability of the Coca-Cola in this machine, right? So the users are able to request for this data from a remote area, and then they can determine whether there's Coca-Cola in the machine and whether that is cold, right? So by making that this machine, they can remotely monitor the Coca-Cola machine and use it, right? So this is the first IoT device that had been implemented in the world, right? And then it is known that the Internet of Things term came after that, and a person called Kevin Ashton was the first person to coin this term and then call this the Internet of Things, right? And then he says he says that Internet of Things is basically like a system where we use the sensors ability to sense things and connection or communication technologies to connect to the build a network of devices and connect those devices to the internet, right? So this Kevin Ashton is a sensor expert right? Sensor and consumer electronic expert, and he has built some IoT systems in supply chains in some supermarkets in US using RFID chips and so on. So IoT is going to IoT is going to evolve in the future as well, and also in the past already some applications have been implemented. For example, in Switzerland, the concept of smart city, and also the smartphone with its developments with related to different sensors installed in it, which enable the smartphone to be one of the best IoT devices. And currently, our smartphone has many capabilities. It has Bluetooth, RFID identification ability, and also near field communication ability, where you can use your phone to do payments by just putting your phone near the payment card machine. So in the future, it is known that IoT is going to be not only Internet of Things, but it's going to be called as Internet of Everything. So everything is going to be connected to the internet. So that is end of, or the end goal of IoT, and then several technologies are also going to be considered in this scenario, where we are going to be connecting machine to machine, and then we are going to build communication between machine to machine directly using technologies. So we have several wireless technologies that we can use. So using those technologies, we can create this M2M. And then Internet of Nano Things, right? So Internet of Nano Things, we have nano scale devices connected to the internet using some communication networks, and it is called as IoT. And then we have something called digital twins, right? So digital twins are also kind of like an evolution of IoT, where we are going to create a visual image of a certain infrastructure in virtual reality environments, right? So we are virtually seeing a certain system at a location that we prefer, and then we do all the simulations using that model that we have created, and using that model we can predict what is actually going to happen in a the remote location in which this infrastructure is in. Okay, so so this is some kind of a new technique that will be coming in the future, but that is also actually something related to IoT, and also an evolution of IoT. So then we have another IoT system that is coming called Super IoT, which is known as Sustainable Internet of Things, that that is based on certain technologies, right? So we'll be using radio and light communications for wireless information and power transfer, right? So the visible light, the lights which we are using in our rooms, in our indoor environments, we will be using to transfer information, to connect to the internet, and also to do energy harvesting at the device levels. So the devices will not drain energy when we are using this Super IoT, and then the devices can continuously send data to the internet using this light-based communications. And then mission critical IoT applications. So we can use IoT for mission critical scenarios as well. So mission critical means like emergency scenarios. So once we have some kind of emergency, we want to send the data very reliably, very accurately, and with low latency to the servers, right? So in those machine type mission critical like Internet of Things, we need to make sure that we send the data very fast and also accurately. So we are talking about ultra reliable, low latency communications in this scenario. So I said as before, like the characteristics of IoT will be that the IoT system will have connectivity. The devices will have the ability to um, I mean, the devices will have a unique identity. So there will be a unique ID that we allocate for each device. There will be unique IP address, for example. And then we have the ability to scale the IoT network and connect like massive amounts of data. And also we need to consider about the security of IoT, and we need to consider about the data storage, management and analysis of IoT, the collected data in the IoT systems. So there are several devices that we are very well known with in IoT systems, and like Alexa, Siri, and such kind of popular like devices are there, which work uh, uh, as a part of the IoT network, and which connect to an IoT network using a certain like communication technology. And so those are very popular IoT devices, which we can see already in the present times. And apart from those devices, we have other applications, other devices for different other applications, like fitness trackers and glucose meters and so on. Right. So at the user level, we have different devices that we use, and all those devices use sensors, and those sensors are able to collect data, and the devices are able to have communication with a local server or a local access point or a base station, and then send the data towards such access points using wireless communication, for example, and reliably send the data to the internet. And using that data in the internet, the smartphone is able to access the data in the cloud, and then measure the whatever the parameter like glucose level, activity, or so on. Right. So there are many wireless technologies that are used basically in IoT systems, and especially in wearable devices such as Bluetooth, right? Bluetooth low energy. Then we have cellular technology like 4G, 5G, and so on. Then Wi-Fi technology, Zigbee technology, near field communication, right? Radio frequency ID, RFID, and so on. So these wireless technologies are widely used for wearable IoT devices. So properties of these wireless technologies must be taken into consideration when we are using such technologies for different applications. So depending on the data rate requirement and the power requirement, the connectivity range that is required, we need to decide what kind of devices we will be using, right? So if we want a high data rate and low power consuming IoT device, then we might need to use Bluetooth, for example. So Bluetooth can send a lot of data, but also it will utilize less power, right? So likewise, based on the application and our requirement, we'll be using a selected communication technology. So lastly, in today's lecture, I would like to give a small activity to you. So this is an activity. This is an activity that I have created for you to do at home, or you can even do it in the next on the interactive class. So uh, are you going to be participating in the interactive class next in the coming I think Thursday? So I don't know whether you're coming to the Thursday's class, but if if required, we can do this as a group activity. But I don't know whether I will be whether I will be missing one batch, a single batch of students, because I think today I did not do the interactive session. So because of that, I will be not be meeting one group of students. Therefore, I will just ask you to do this activity as an individual activity, and then I will ask you to upload the results into the LMS, and I will upload the activity in the LMS. So this is the activity I am asking you to do. So you need to choose some popular IoT devices, and then you need to separate out the components of such devices in terms of the power unit in those devices, whereas the communication unit, the sensing unit, and so on. So what you need to do is you need to take an image of the IoT device and point out the location of the power unit, the communication unit, the sensing unit, the processing unit, and such kind of like the basic units that are available in the IoT device. You can mention in the image, you can label, and then that is all that you have to do. So you need to do that for about 3 devices that you like, and then you can submit, right? So you can individually choose your devices. Please don't copy, right? So I want some kind of uniqueness between your assignments, right? So that's all actually I would like to give as assignments for this course. So do you have any questions regarding today's lecture? Okay. Is this an open book module? That means what? I mean, exam? You're asking about the exam. Okay, so I don't know exactly what it's going to be, but most of the time it would be closed book, I think. But I mean, I will be doing some tutorials before the exam, and if you are comfortable with the tutorial, you will be able to perform well in the exam. So all the tutorials I will be doing in the interactive sessions, right? So I would like to invite you to come to the interactive sessions and get the questions and discuss the answers in the class, and prepare for the exam like that, right? So the closed book exam is given because mainly I think currently it's very hard for us to do these open book exams, but like it depends. Sometimes my decision can change in the future. So currently my decision is that I'm going to be doing this as a closed book exam. Are there any more questions? Do you have any more questions? And also, if you have any, yeah, I will upload the PDF to the LMS. And if you have any questions related to any of the information that I have shared with you in the presentation, I would like you to ask questions from me. Even in the WhatsApp, it's totally fine. I hope you have joined the WhatsApp group that is intended to this course. I have given the link to the group in the LMS. So you can access the group chat using that link, and then you can ask any questions. And then even in the class, we can talk about the questions we have, and then we can resolve such questions. So I will be ending the course, the class now. So I hope you had a good lecture. So thank you for attending. So see you at the interactive session. Thank you.